the rate of water loss is greater than the water what? Remember, water loss is happening by what? By transpiration. Water uptake through the roots. So now we've got the rate of water loss is greater than water what? Than water uptake. So it causes wilting. That making sense? By which process is water lost through the leaf? I even mentioned the other day, and I said it's never osmosis. It's what? Diffusion. Because we're talking of water vapor. The lower end of the plant stem is placed in water colored with a dye. I said this affects the xylem. Was it's the xylem vessels that what? That take up water. Clear? Which so is the xylem, this one, the xylem, from what you said. What is transported in the phloem and in what is the direction of transport? What did he say about the xylem? Who remembers? The xylem is only upwards.
Upwards.
Upwards only. What did he say about the phloem? He said in both directions. That's what he said. Because we're talking of translocation here. So it can be in both directions. Making sense? So what's the best answer? Number 5? Sucrose down and up. In amino acids, down and up. Area of production to area of utilization or area of storage. In which water does water pass through the cells? I think I even gave you this in a notebook. Is that true? I gave you this. Who remembers that I gave you this in the notebook? Well, how can you get it wrong when it's in the notebook? The diagram shows you a plant shoot and the same shoot 6 hours later. Okay. 6 hours later. What change in the environment could have caused this? What change in the environment could have caused this? So you can, what is this? Isn't this wilting? Again, do you agree? It's wilting. So it's caused by a decrease in availability of what? Of water. Now, which diagram shows you? Okay, now remember, so we have got that stem there. Shows you the appearance at the end of the stalk. Okay, when you cut it and observe it, you can't have, remember, it's only the xylem vessels that will be what? That will be colored. Clear? Remember, I even gave you the experiment. It's only the xylem vessels that will be colored because they are taking up water. What is found at Q? What is Q? The xylem. Do you agree?
Yes.
What is this? The folium. The cortex, epidermis. We need to know all that. What is found at Q? Xylem. How am I saying they were not seeing clearly? I don't know. On this part, maybe. Which processes produce a continuous space for the flow of water in what? In the xylem. Removal of cytoplasm. Oh, okay, I see. So maybe people are not seeing. So breakdown of the adjacent walls, yes, between that. So what's the answer? A, yeah. And there's no cytoplasm adaptation. Some liquid is collected from the xylem in the stem of a plant. What is present in this liquid? So we've collected in the xylem. So organic ions, remember? And water. What is the function of folium? Translocation. translocation, and I gave you the definition. Clear? The diagram shows you part of a trunk of a small tree with a ring of a bark removed. Removing the ring of the bark takes away the folium, but leaves the xylem intact. The xylem is not affected. There's a breakdown here. The growth surface will be reduced because you're having transportation of amino acids and whatever sucrose affected. The leaves, photosynthesis takes place in the leaves. The leaves still have got water. Do we agree that the leaves upper branch, or taking lower branch and the upper branch? Growth normal, leaves normal. So what's the best answer then? Number 13. So your growth is affected, this, but your leaves, they are normal because they still have the water and they are photosynthesizing. So the best answer is C. Are we together? The table shows you some characteristics of 4 different plants. The plants are growing in the same environmental conditions. Which plant will have the highest rate of photosynthesis? The highest rate of photosynthesis. So you want with the high number of leaves, it's obvious. The more leaves, the higher the rate or whatever. Large surface area, yes.
Wait,
I agree.
is it not the highest rate of transpiration?
Highest rate of transpiration. Sorry, did I say photosynthesis? Transpiration. So the
Yeah.
higher the number of leaves, the higher, the amount of water that will escape. So the larger the surface area, that increases the rate of photosynthesis. Clear? Your stomatas, the higher the number of stomatas, the higher remember the openings. So what's the best answer there? A decrease in which factor normally causes an increase? It's only humidity. Yeah? What is the path? They've repeated this, which means if you failed the other time, what is the path of water through a plant? Root hair to xylem to fall mesophyll cells to what? Stomata. The different person. What is the order? Okay, in which order does water pass through the tissues in a plant? In which order? We want the correct order. So root cortex, xylem, and mesophyll has to be the end because it's in the leaf. Clear. The xylem starts away from the center of the roots. Now, let's see what they are investigating. The diagram shows you tissues at the start of an experiment on transpiration. First, X there, then I put oil. Of oil, then we have water. Then we have a spring balance. Okay, so this one doesn't have leaves, huh? That's the difference. Do you agree? What are the likely readings on the spring balance after 3 days? After 3 days. I'm saying C. A reduction in the weight of, so this one transpiration takes place. Huh? This one there are no leaves here. Yeah. Are we together? There are no leaves. So best answer there, correct. C. Which statement about plants transpiration are correct? Which statement about plant transpiration are correct? So which one is the best answer? Plants transpire most when we're talking of, or when what? Light intensity is high. Correct. When light intensity is low, wrong. When temperature is wrong, no, there's to be high temperature. When the air is dry, correct, low humidity. But last, let's look at this here. Clear? To guide us to plants transpire least when what? When temperature is high. That's wrong here. Clear? When the air is what? Is humid. High humidity, low transpiration. So the answer becomes what? B. Clear? The table shows you the rate of water flow through a tree for a 24-hour period. Okay. Time of day, rate of water. Okay, like that. What conclusion can be drawn from the table? What conclusion can be drawn from the table? The greatest rate of what is between that? Do you agree there? There. What's the difference there? What's the difference here? 20. Huh? What is the difference there? One what? 110.
10.
The difference there 50. The difference there 40. The difference there that 260. What's 260 minus 180? 80. Yeah? So there, that's the answer. It's from the diagram. You don't need to read about it. Clear? An obvious answer. Which words correctly complete the following sentence? Transpiration is dash of water at the surface of dash cells followed by dash. Remember I gave you that definition? Everybody remembers that I gave you the definition? You remember?
Yeah.
So transpiration is the evaporation of water at the surface of the mesophyte what? Cells, followed by the loss of water vapor from the plant leaves. The definition that I gave you. What could increase the rate of water uptake by a sheet? What could increase it? The rate of water uptake. Removing the leaves, no. So shining a bright light, increasing light intensity. Water vapor. So by which process is water loss? Transpiration.
Transpiration.
Then we've got a diagram which shows you a cross section through a plant stem. Okay, they're now asking about Q. Q shows you parts that is turned red when the stem is placed in water containing a red dye. Okay, xylem. Please skip anything. Oh, wait, skip this. We say the only graph that is like this is a humidity graph. In what form does a plant absorb and lose water?
Yeah.
It absorbs water as a liquid
Liquid.
and loses water as a vapor. In what order does water pass through these structures? We are only given 3 structures. Root hair, xylem to mesophyte on the leaf. Which 2 substances are transported in the following? Again, you see your notes, amino acids. Super.
Chris.
What is a description of transpiration? It means the best description from what you are given. The loss of water vapor through whatever, clear? According to those definitions. Diagram shows the strip of tissue, including the following, has been removed. Okay, more like a similar question. How is transport in the plant affected? How is transport in the plants affected? Amino acids and what cannot pass through, we have removed what? The volume. The diagram shows you a plant. Let's see, X, W, X, Y, Z. What is the path taken by most water absorbed by this plant? So we wanted the best path. So it's from Z, then to Y, Z to Y. So the answer becomes obvious. Oh, this was an easy. Should have. No one got 100%. The answer was 95 or something. The diagram shows the two stages in the passage of water through a plant. The circles are the starting points for arrows to show the direction in which water moves. Which circle must have an arrow pointing downwards? Downwards. An arrow pointing downwards. So what are the arrows showing? Direction in which water moves. The direction in which water moves. Okay. So the stomata, water is moving away. Downwards, out. Clear? Number 33. Translocation occurs in the phloem tubes. Aphids feed on the contents of the phloem tubes. What type of food would be lacking in their diet? What type of food would be lacking in their diet? So they feed on the amino acids and the sucrose. So what do they lack?
Veg.
Now, which two functions does the xylem perform? We talked about support, support and what? What's the best answer there? Number 34.
Conduction.
Conduction. Okay. Conduction. Remember, what are we talking of conduction? With xylem, we have cohesion and what? And adhesion. So we're saying, remember, water has got a tendency as it is moving, particles sticking to one another. Sticking to one another, clear? That's why we're talking of the conduction here. That's where it's coming from. And the particles, they also have a tendency of sticking to the xylem. The walls as they move, clear? So that's where the conduction is coming from. How to get and support.
Yes.
Now the diagram shows you a cell from a storage organ of flowering plant. Just for them. After having been stained with iodine solution. Which structures X stained black? What does this show about the structure? What does this show that the structures X contain? The structure. So they are stained what? Black. What do you know about iodine? If it's black, blue black, it means starch is what?
Present.
Is present. Huh? It has nothing to do with transpiration. It was just thrown there. Clear? Some of this, that's why someone was saying I was not seeing clearly. Which shows the correct translocation of carbohydrates in a potato plant that is growing in bright sunlight. Source of carbohydrates. Source of carbohydrates. Carbohydrate is manufactured in the leaves. Huh?
Yeah.
Type of translocated is the glucose that is translocated. Clear? We don't translocate it. They are digested. Clear? It's the glucose that is translocated. The sucrose. Clear? They're making sense.
Sucrose, yeah, not
Sucrose, not glucose. We don't talk of translocation. We talk of amino acids and sucrose. Clear?
mhm.
So it means B is the answer. Which conditions of humidity, light intensity, and temperature makes transpiration the slowest? So we need the slowest. It means high what? High humidity. High humidity. So humidity has to be very high. So this is out here. This is out. Humidity has to be high. Light intensity has to be what? To be lower. Temperature has to be low. So that's the answer. D. So wilting, which condition causes this? So what's the best answer there? Humidity.
B.
Remember, it's wilting. So it means if the rate of water uptake is greater than the rate of water loss, water loss greater than water uptake. So it means more transpiration is taking place. So if more transpiration is taking place, so what does that mean about the humidity? Low what?
It's low.
Low humidity. Light intensity, high. So what's the answer? Clear? Or waiting to take place. The table shows you 4 substances and the parts of the plant to which they are transported. Okay. Substance, part of plant. Which are the examples of translocation? Is that the last part? Translocation. So sucrose, amino acids. Clear? Maybe. Now let's look at experiments. That's what we want to consider. That's the last thing for today. Then we will look at a new topic that we need to finish by next week before exams. Okay. Now, I talked about experiments. Remember we said how many factors affect rate of transpiration? We said light intensity.
Humidity, light intensity.
We said what? Temperature. Who remembers? We said what? Humidity. And lastly,
wind and humidity.
We said the wind on its own. And speed to be specific. Clear? Those are the 4 factors that affect the rate of transpiration. Now, how do we measure? What do we use to measure rate of transpiration? Who knows? What apparatus? What is it called? Who knows? Who has been reading? Rate of transpiration, what do they use?
Dye.
That's not to measure. That is to see, to investigate how water flows. To investigate how water, the path taken by water through the xylem. It has nothing to do with a dye. Now, what do we do? Laila, what do we use to measure the rate of transpiration? So you guys, I said go and read that. You didn't read. Because no one knows. Ella, what do we use to measure rate of transpiration? Is she in the lesson? I think so. What do we use to measure rate of transpiration? We use what is known as a what? A potometer. We use what is called a potometer. Okay. That's what we use. There. We use what is known as a potometer. A potometer is used to measure rate of what? There. We use what is known as a potometer. So you can write that a potometer is used to measure the rate of transpiration. A potometer is used to measure the rate of transpiration. Clear? A potometer, if you can summarize that, what I'm saying here is used to measure, very important, the rate of transpiration. These I'll send you these notes here that you can read, but we want to talk about them just now. A potometer is used to measure the rate of transpiration. Then NB, which is more, a potometer does not measure the rate of transpiration directly. Clear? A potometer does not measure the rate of transpiration directly, but it measures the rate of water uptake. But it measures the rate of water uptake. So scientifically, they haven't found a way to measure the rate of transpiration directly. Clear? We measure the rate of water uptake. So that's why I said the NB. A potometer does not measure the rate of transpiration directly. Instead, it measures the rate of water uptake. Now, I think some of you are having questions now. Why are we measuring the rate of water uptake? Because it means our experiments are wrong. Because that's not transpiration. What's the reason? What's the logic behind? What's the reason? Who knows what's the reason why we measure water uptake? And conclude based on that. Why do we use that, Kuda?
I think it's because the faster the rate of transpiration, the more water.
Not really. It's because 90% of the water. So you can write the reason. Because 90%, 97% of water is lost. 97% of water absorbed by a plant. Scientists, they discovered that 97% of the water absorbed by the plants from the roots is lost through transpiration. Clear? 97% of the water absorbed by any plant from the ground is lost through transpiration. So only 3% is used by photosynthesis and some chemical processes. Clear? Only 3% is used by photosynthesis in some processes. So that's why we can use that. Is that making sense? Is that making sense why we can use that and conclude that we are measuring transpiration?
Yes.
Because 97% of that is transpiration. Clear? Now, what's important now when we are doing experiments? For example, remember we talked about the four of them. So if I want to measure humidity here, if I want to investigate humidity using this, it means all the other three factors have to be constant. All the other factors, what I'm only changing is what I want to investigate, which means the light intensity has to be constant. Clear? Can be in a room where there's same light. Light intensity, the wind speed has to be constant. Clear? For those experiments that I'm clear. The temperature has to be constant. I hope it's making sense. You only change what you're investigating. Clear? Is that making sense? Now, this one is the tricky one of all the. How do you investigate that humidity? Remember I said the high humidity, it means low transpiration. How do we investigate that? Humidity. How do you change so that one is in a different humidity? How do you do that? Because now in your atmosphere, you've got the same amount of humidity. How are you going to do that? Who knows? So it's you cover one leaf here, or you can, what you can do is you can leave this one, like this here. Let's say I've got a setup like this. Then this one, it's like this, so it's exposed to that. Then in the other setup, I can use two different plants. Then in the other setup here, I cover a leaf like this with what? With plastic. So I cover with plastic the other plant. So I've got two plants. One is not covered, the other one is covered in plastic. What is plastic going to do? When transpiration takes place, let's agree, it's water vapor. Water vapor. Water as a gas. What will happen to the water? Can the vapor escape? It can't escape. So it will what? It will condense. So you see, this creates what? This eventually creates a humid what? A humid condition.
Environment.
In a humid environment. And that humid environment is going to lower your what? Your transpiration. Clear? So in terms of the potometer here, because there's a capillary tube that moves, it's explained that this will move. I mean, the movement will be a low, because remember this is measuring water uptake. So the water uptake here will be lower than the one where it doesn't have plastic. The capillary tube will move to a greater distance, clear, because the transpiration is what? Is great. Altogether, then we can conclude that the higher humidity lowers the what? The rate of transpiration.
Yeah.
What about wind speed? How do we change the wind speed? What do we use?
A fan.
We can use a fan, correct. So one, we can use a fan, like what he's saying. One, we can just expose it to your natural wind. Then the other one there, you use fan, clear. You can actually use fan, and with the fan, maybe you can actually test different wind speeds and checking each time, clear. So we can use a fan, that's true. Temperature?
An acorn.
Not really.
For
temperature, we can use, just like your photosynthesis, we can use a light source. A light source, we measure the distance, clear? The light source, then we change the distance. If the light source is closer, of course, you give it time to adjust. A light source is closer, it means a higher temperature, clear? You expect the transpiration rate to be greater. But it's all explained. I said I'm going to send you these notes. It's talking of rates of water uptake in different conditions. And it explains everything and the expected results. Clear? Then the other one of the stomatas, this experiment, go through that thing. The investigator, you expect the underside of the leaf to have many stomatas. So the other one can be covered, I think, with Vaseline there to do that experiment. But anyway, you can read this. So I said I'm going to send on the group. Is everyone on the school group? School group.
Which school group? The
school group, the study group.
Yeah.
Are you in the study group? Because I will send to one of you so that I don't have to send to everyone. Then she will send just now. I'm going to send to Laila to send on the school group. These notes there. So if you want, you can actually print if you've got the print at home. Maybe if you don't have, you can write them. They're very important notes. They've got the experiments, clear. I just want you to concentrate mainly on the experiments, because there are other things on this, but concentrate mainly on the experiments. That's the last section. Then what I'm also going to do is I'm going to send you theory questions with answers. So that you try, because we are done with the topic on transpiration. You can try on your own, then you can actually check the answers. What's expected, what they expect, how they expect you to respond. And in
Right.
terms of marks, clear. It's clearly it's a proper marking schema. Clear. So I'll send you to try them on your own. We are done. So we are moving to the endocrine system and nervous system. That's the end of the
All right.
before for exams. Endocrine system, your hormones, and we talk about the nervous system, the neurons.
All
Clear.
right.
Before the exams.
Yeah.
Okay. So we are done for today.
Bye bye.
See you later. Okay.
Thank you, sir.